Look up at the night sky. Everything you see, the stars, the planets, the vast, dark emptiness, it all feels infinite, right? But what if I told you there is an object out there so unimaginably massive that our entire solar system, including the sun and every single planet, would look like a tiny, insignificant speck of dust inside it? Today, we are talking about an object that doesn't just break the rules of space, it rewrites them. We are talking about Phoenix A star, the largest black hole ever discovered in the observable universe. Now, to understand how big this monster is, we first need to look at our own home. Our solar system is huge. From the sun to the farthest planet, Neptune, the distance is about 4.5 billion kilometers. If you go even further to Pluto, you are looking at nearly 6 billion kilometers. To us humans, that is a distance we can barely comprehend. It took the New Horizons spacecraft 9.5 years just to reach Pluto, traveling at speeds over 50,000 kilometers per hour. But in the presence of Phoenix A star, that entire multi-billion kilometer journey is nothing more than a microscopic step. You see, Phoenix A star is what scientists call an ultramassive black hole. It sits at the heart of the Phoenix cluster, a massive group of galaxies located about 8.5 billion light-years away from Earth. For years, astronomers thought a black hole called Ton 618 was the undisputed king of the cosmos. But Phoenix A star has recently taken the crown. Its mass is estimated to be a staggering 100 billion times the mass of our sun. Just think about that for a moment. If you took 100 billion stars like our sun and crushed them into one single point, you would finally have the weight of this one single object. But it is the physical size that is truly terrifying. The diameter of this black hole's event horizon, the famous point of no return, is roughly 590 billion kilometers. To put that in perspective, that is 100 times the distance from our sun to Pluto. If you replaced our sun with Phoenix A star, it wouldn't just swallow the Earth. It wouldn't just swallow Jupiter or Saturn. It would swallow every planet, every asteroid, and the entire Kuiper Belt instantly. Our entire solar system would be lost in just a tiny corner of its shadow. This isn't just a black hole. It is a cosmic abyss that challenges our very understanding of the universe. But how do we even find something that is billions of light years away and, by definition, completely invisible? The story of how we discovered Phoenix A star is almost as fascinating as the black hole itself. Back in 2010, a team of astronomers wasn't even looking for a record-breaking black hole. They were using the South Pole Telescope in Antarctica to study galaxy clusters, huge groups of hundreds or thousands of galaxies held together by gravity. While scanning the southern sky, they stumbled upon something that shouldn't have been possible. They found the Phoenix cluster, located billions of light years away from us. Now, usually, when we look at the centers of massive galaxy clusters, they are dead zones. The giant galaxies at the heart are usually full of old red stars, and very little new star formation is happening. This is because the central black hole usually heats up the surrounding gas, preventing it from cooling down and forming new stars. But the Phoenix cluster was different. It was screaming with energy. This cluster was emitting more X-rays than any other galaxy cluster ever observed. And at its very center sat the galaxy Phoenix A. Scientists were shocked to find that this galaxy was producing new stars at an unbelievable rate of about 740 stars every single year. For comparison, our Milky Way galaxy only produces about 1 or 2 new stars per year. This galaxy was like a cosmic factory running on overdrive. But what was providing all that energy? The answer, as it turns out, was a monster hidden in the dark. To power such a massive display of energy and star formation, there had to be an equally massive engine at the core. When researchers used detailed models to analyze the movement of gas and stars in that central galaxy, they realized the black hole wasn't just big, it was off the charts. It was estimated to be 100 billion times the mass of our sun. And here is the most terrifying part. This monster is still growing. Most supermassive black holes eventually reach a size where they run out of nearby food and quiet down. But Phoenix A star is currently in a massive feeding frenzy. It is consuming the equivalent of 60 of our suns every single year. Imagine that. Every few days, a star the size of our sun is ripped apart and swallowed by this abyss. This constant consumption is what creates its massive accretion disk, a swirling ring of superheated gas and dust that glows with enough energy to be seen across the entire observable universe. To give you a better idea of how massive 100 billion suns really is, scientists had to create a whole new category just to describe it. Most people are familiar with supermassive black holes, like the one at the center of our Milky Way. But those are like pebbles compared to this. Phoenix A star is classified as an ultramassive black hole. While a supermassive black hole might be a few million or billion times the mass of the sun, an ultramassive one is in a league of its own, starting at 10 billion solar masses and going all the way up to where Phoenix A star sits, at the very edge of what physics says is even possible. Now, let's talk about the physical space this monster occupies, because this is where it gets truly terrifying. The event horizon, the black sphere, where gravity is so strong that even light cannot escape, is about 590 billion kilometers wide. To put that in perspective, remember that Pluto is roughly 6 billion kilometers from the sun. That means the event horizon of Phoenix A star is nearly 100 times the distance from the sun to Pluto. If you were to stand at one edge of this black hole and try to shine a flashlight to a friend on the other side, it would take your light 22 days just to cross the diameter. But here is the most mind-melting fact of all: the circumference. If you wanted to take a trip around the outer edge of this black hole in a spaceship traveling at the speed of light, the fastest speed allowed in our universe, it wouldn't take you a few hours or even a few days. It would take you 71 days just to complete one single lap around the edge. Imagine that. 2.5 months of traveling at 300,000 kilometers per second just to circle one single object. And yet, despite being this massive destroyer of worlds, Phoenix A star is at the center of a very strange cosmic paradox. Normally, when a black hole gets this big, it becomes a killer. It releases so much heat and radiation that it blows away all the gas in its galaxy, stopping any new stars from being born. It essentially chokes its own galaxy to death. But Phoenix A star is different. Even though it is eating 60 suns every year, the galaxy around it is still managing to give birth to 740 new stars every year. It's a scene of ultimate destruction and ultimate creation, happening all at the same time. Now, you might be thinking, surely there's a limit to how big these things can get, right? For a long time, scientists thought there was. They have a theoretical limit of about 50 billion solar masses. The idea was that once a black hole gets that heavy, its accretion disk, the ring of gas it feeds on, becomes so massive that it starts to collapse under its own gravity and form stars before the black hole can even eat it. It's like a person trying to eat a pizza that is growing so fast it turns into a giant garden before they can take a bite. But Phoenix A star didn't get the memo. At 100 billion solar masses, it is double that theoretical limit. This is why Phoenix A star is the king of a new class of objects, the ultramassive black holes. To give you some perspective, let's look at the previous record holder, Ton 618. For decades, Ton 618 was the scariest thing in the sky, weighing in at 66 billion suns. We thought that was the absolute peak of cosmic gluttony. But Phoenix A star makes Ton 618 look like a middleweight. And if you compare it to Sagittarius A star, the black hole at the center of our own Milky Way, the difference is just insulting. Phoenix A star is 24,000 times more massive than our galaxy's central black hole. If our black hole were the size of a single marble, Phoenix A star would be larger than a stadium. The physical scale is where your brain really starts to hurt. We mentioned that its event horizon is 590 billion kilometers wide. In space terms, that is about 3,900 astronomical units. One astronomical unit is the distance from the Earth to the Sun. So this black hole is 3,900 times wider than the distance between us and our star. If you place this monster where our Sun is, the event horizon wouldn't just stop at Pluto. It would extend all the way out to the inner edges of the Oort cloud, the theoretical shell of icy objects that surrounds our entire solar system. But how does something this big even form? It couldn't have come from a single star, no matter how large. Stars just don't get that big. The leading theory is that Phoenix A star is the result of a cosmic pileup. Billions of years ago, in the very early universe, multiple supermassive black holes must have collided and merged over and over again. It is a product of galactic cannibalism on a scale we can barely imagine, and it is still happening today. Now, you might be wondering, what does a galaxy look like when it is being ruled by such a dominant, terrifying force? In most massive galaxy clusters, the central black hole acts like a cosmic thermostat. It releases massive jets of energy that heat up the surrounding gas, preventing it from cooling down and forming new stars. This is why most old galaxies are red and dead. But recent discoveries from the James Webb Space Telescope have revealed that the Phoenix cluster is breaking all the rules. In early 2025, scientists using the James Webb Telescope found the missing link in this mystery. They discovered pockets of warm gas, around 300,000 degrees Celsius, which bridges the gap between the ultra-hot gas of the cluster and the ice-cold gas needed to make stars. This proves that the Phoenix cluster is actively cooling at a rate equivalent to 20,000 suns every single year. Because the gas is cooling so efficiently, it creates a fire hose of star formation. While our Milky Way makes maybe one star a year, the galaxy around Phoenix A star is churning out nearly 1,000 new stars every year. It is the most prolific star factory ever seen in the distant universe. But Phoenix A star itself is going through a massive identity crisis. Astronomers have found that it is currently operating in two different modes at the same time. Half of its energy is being blasted out through massive mechanical jets that plow into the surrounding gas. This is called radio mode. The other half of its energy comes from the blinding light of its accretion disk, known as quasar mode. It is essentially flipping between two of the most powerful states a black hole can inhabit, creating a level of turbulence and energy output that is almost impossible to calculate. Now, here's a question that might blow your mind. If you were to fall into Phoenix A star, what would happen? Usually, we think of black holes as spaghettifiers that rip you apart the moment you get close. But because Phoenix A star is so unimaginably large, a strange quirk of physics takes over. You see, the tidal forces, the difference in gravity between your head and your feet, are actually much weaker at the event horizon of a giant black hole than a small one. This means that if you were in a spaceship, you could actually cross the event horizon of Phoenix A star and feel absolutely nothing. You would be inside the point of no return, trapped forever in a 590 billion kilometer wide abyss, and you wouldn't even know it happened until it was too late. But while you might feel nothing physically as you cross that line, the visual and temporal reality around you would be breaking in ways that are hard to even describe. As you fall deeper into Phoenix A star, the light from the universe behind you would begin to warp. Because gravity is bending space-time itself, all the light from the billions of stars and galaxies in the outside world would be squeezed into a smaller and smaller circle behind you. It is like looking out of a shrinking window. Eventually, that window would turn into a tiny, blindingly bright ring of light. And then, total darkness. And then there is the time dilation. This is where things get really spooky. Because of the extreme gravity, time for you would slow down to a crawl compared to the rest of the universe. While only a few minutes might pass for you as you approach the singularity, millions of years would be passing in the outside world. You would literally be watching the entire future of the universe play out and fast forward right before your eyes. You could witness the birth and death of entire civilizations, the collision of galaxies, and the fading of stars, all in the time it takes to blink. But let us step back outside the event horizon for a moment and look at the engine that makes all this possible, the accretion disk. This is the swirling ring of matter that Phoenix A star is currently eating. We mentioned it swallows 60 suns every year, but the scale of this dinner table is just as massive as the black hole itself. The accretion disk of Phoenix A star is so large and so hot that it makes it the most powerful producer of X-rays in the entire known universe. For years, scientists were confused. They could not understand how a black hole emitting this much heat had not completely killed off its host galaxy. But in February 2025, the James Webb Space Telescope finally solved the mystery. It found a missing link: pockets of warm gas, about 300,000 degrees Celsius, that act like a bridge. This gas is cooling down fast enough to overcome the black hole's heat, providing the fuel for that incredible star formation we talked about. Phoenix A star is essentially a chaotic balance between a cosmic furnace and a cosmic nursery, and we are only just now beginning to understand how that balance works. Now, you might be thinking that because it is called a black hole, Phoenix A star must be a dark, invisible void. But the truth is exactly the opposite. Phoenix A star is one of the brightest and most energetic objects in the entire known universe. This is because of its active galactic nucleus, or what astronomers call a quasar. As matter, stars, gas, and dust spirals toward the event horizon, it doesn't just fall in quietly. It gets squeezed and rubbed together so violently that it heats up to millions of degrees, releasing a blinding amount of radiation. In fact, the Phoenix cluster holds the record for the highest X-ray luminosity ever discovered. It produces more X-rays than any other massive galaxy cluster we have ever seen. But here is where it gets really strange. NASA scientists have discovered that the black hole at the center is actually suffering from a bit of an identity crisis. You see, half of its massive energy output is being blasted out through physical jets that push on the surrounding gas, which is typical for a radio galaxy. But the other half of its energy is coming from the intense light and UV radiation of its accretion disk, which is the hallmark of a quasar. Astronomers believe we are catching this monster right as it is flipping between these two different states, a rare cosmic transition that we are lucky to witness. But how did it ever reach 100 billion times the mass of our sun? This is the ultimate question that keeps astrophysicists awake at night. According to the latest research from late 2024 and early 2025, scientists believe that 100 billion solar masses might be the absolute theoretical limit for how big a black hole can get. Beyond this point, the black hole's own energy output becomes so powerful that it literally blows its own food away, preventing any further growth. This means Phoenix A star isn't just the biggest black hole we've found. It might be the biggest black hole that can ever exist in our universe. It likely didn't start as a single star. Instead, theories suggest it may have formed from the direct collapse of massive primordial gas clouds shortly after the Big Bang, or through thousands of mergers where smaller supermassive black holes collided and became one. It is a relic of the early universe, a sleeping giant that has been feeding for nearly 10 billion years to reach this terrifying, record-breaking size. Now, you might be asking, if Phoenix A star is this massive and hungry, why hasn't it eaten its entire galaxy yet? This brings us to one of the most incredible discoveries in modern astrophysics, the concept of a cosmic feedback loop. Think of the black hole as a giant thermostat. As it feeds, it releases massive amounts of energy that heat up the surrounding gas, pushing it away and actually stopping the black hole from eating too much. It's a self-regulating system that prevents these monsters from growing infinitely. Without this mechanism, the universe would likely be a very different, much emptier place. In fact, just recently, in late GDK4 and early 2025, researchers from Yale University established a theoretical cap on black hole growth. They found that 100 billion solar masses, the exact mass of Phoenix A star, is likely the absolute limit. Beyond this point, the black hole's radiation becomes so powerful that it literally blows its own food supply out of the galaxy, effectively starving itself. This means that Phoenix A star isn't just the king of black holes. It is likely the largest black hole that can ever exist in our universe. It has reached the literal finish line of cosmic growth. It is an object that has hit the ceiling of physics. But even at this limit, the black hole isn't quiet. It is constantly singing to its galaxy. You see, as the black hole blasts out energy, it creates massive pressure waves, basically ripples of sound, that travel through the hot gas filling the cluster. While we can't hear this with our ears, these ripples act like a heartbeat, carrying energy across millions of light years. In other galaxy clusters, we've actually used X-ray telescopes to see these ripples and translate them into a deep, haunting hum. These are the deepest notes in the universe, billions of times lower than anything a human ear can detect, where a single vibration can take up to 10 million years to complete. In the Phoenix cluster, however, the thermostat is currently failing. The James Webb Space Telescope recently discovered a missing link, pockets of warm gas that act as a bridge between the boiling cluster and the freezing cold needed to make stars. This proves that the gas is cooling down much faster than the black hole can heat it up. This is why the central galaxy is still producing stars like a factory, creating 1,000 new suns every year while the black hole sits at its maximum weight, struggling to regain control. We are witnessing a rare moment in cosmic history where the balance of power has shifted, and the result is the most energetic display in the observable universe. Now, if the light of the accretion disk wasn't enough to terrify you, let's talk about the weapons this monster uses to keep its entire galaxy cluster in check. While Phoenix A star is swallowing matter, it is also spitting it out. This black hole generates two massive, opposite-pointing jets of plasma that are blasted into space at nearly the speed of light. These aren't just small streams of fire, they are relativistic beams of destruction that reach far beyond the boundaries of the central galaxy itself. Look at the images from the Chandra X-ray Observatory, and you'll see something haunting. Giant dark holes in the glowing hot gas surrounding the galaxy. These are called X-ray cavities, and they are essentially cosmic bubbles that the jets have punched into the cluster's atmosphere. How big are these bubbles? Each one is about 100,000 light-years wide. To put that in perspective, one single bubble is the size of our entire Milky Way galaxy. Imagine a black hole so powerful that its breath can blow a hole in space large enough to fit 200 billion stars. The energy required to create these cavities is almost impossible to calculate. Scientists say the power behind these outbursts is among the most energetic events ever recorded in the history of the universe. We are talking about a power output equivalent to trillions of suns being released every single second. This is because the black hole is trapped in what astronomers call an identity crisis. It's operating in two modes at once: the quasar mode, where the disk glows with blinding light, and the radio mode, where these massive jets act like physical battering rams. But here is the craziest part. These jets are actually playing a double game. Usually, jets are killers. They heat up gas and stop stars from forming. But in the Phoenix cluster, these jets might actually be creators. Recent research from 2024 and 2025 suggests that as these jets plow through the cluster at relativistic speeds, they create shock waves that might actually be helping some of the gas to cool down in their wake. It's like a giant cosmic plow that is turning the soil of the universe. As the jets push outward, they leave behind massive filaments of gas and dust, some stretching over 300,000 light-years long, where new stars are rapidly born. It is a chaotic battle between total destruction and a literal explosion of life. And right now, the galaxy is producing stars 740 times faster than our own. But here is the catch. This incredible cosmic fireworks show cannot last forever. In fact, compared to the life of a galaxy, it is just a blink of an eye. Scientists estimate that this massive growth spurt will only last about 100 million years. That might sound like a long time to us, but in the history of the universe, it's a very short window. If Phoenix A star kept growing at this rate for any longer, it would become so massive that it would literally destabilize the entire cluster. It is currently in a state of unsustainable gluttony, racing toward a finish line that physics has set for all objects in the universe. And this brings us to one of the most important scientific breakthroughs of early 2025. Dr. Priyamvada Natarajan and her team at Yale University have recently confirmed that Phoenix A star is sitting right on the edge of the absolute maximum size a black hole can achieve. They found that once a black hole hits roughly 100 billion solar masses, its own energy becomes its undoing. The heat and radiation are so intense that they push away all the gas in the surrounding area, cutting off the black hole's food supply. Phoenix A star has essentially hit the ceiling of the universe. It is the ultimate heavyweight champion, and it's unlikely we will ever find anything bigger because, according to the laws of nature, anything bigger shouldn't be able to exist. Now, take a second to think about where this monster actually is. Phoenix A star is located about 5.8 billion light-years away from Earth. This means the light we are seeing today actually left that galaxy 5.8 billion years ago, before our own sun or the Earth were even born. We are essentially looking into a time machine. The Phoenix A star we see today is the version from the distant past. What does it look like right now, in the present day? Some astronomers believe that by now, the feeding frenzy might have already slowed down. The thermostat might have finally kicked in, and the black hole could be entering a much quieter, dormant phase. But even if the black hole slows down, the Phoenix cluster itself remains a terrifying kingdom. It is 2,000 times more massive than our entire Milky Way galaxy, containing thousands of individual galaxies all held together by the invisible grip of dark matter and the gravitational pull of this one central monster. It is the most extreme environment we have ever discovered, and it teaches us that the universe is far more violent, energetic, and unpredictable than we ever dreamed. So, where does all of this leave us? When you look at an object like Phoenix A star, it is easy to feel completely insignificant. After all, we are living on a tiny blue rock, orbiting a middle-aged star, in a galaxy that is just one of trillions in the observable universe. To put it in perspective one last time, if our sun were the size of a single grain of sand, the event horizon of Phoenix A star would be larger than the entire city of New York. It is a scale that our human brains simply were not designed to comprehend. Now, you might be wondering why we even care about a monster that is billions of light years away. Well, the answer is that Phoenix A star represents the ultimate ceiling of our universe. It shows us exactly how far the laws of physics can be pushed before they start to break. We now know, thanks to research finalized in early 2025, that 100 billion solar masses is likely the absolute maximum size a black hole can achieve before its own radiation blows its food supply away. It is the heavyweight champion of the cosmos, a title it will likely hold forever. But there is also something deeply poetic about this giant. As we have seen, it is not just a destroyer. Through the cooling flow mystery that the James Webb Telescope recently solved, we now know that even in the presence of the most powerful abyss in existence, life, in the form of stars, finds a way to be born. It is a chaotic, beautiful cycle of death and rebirth, happening on a scale so large it takes 71 days for light itself to just circle the edge once. The craziest thing is that we are looking at this black hole as it was nearly 6 billion years ago. That light started its journey before our sun or the Earth even existed. We are literally peering into the deep history of the cosmos, and the fact that we, tiny humans on a tiny planet, have the technology and the curiosity to measure the mass of a godlike object billions of light years away is the real miracle. Our journey through the dark does not end here. The universe is full of these limit breakers, and every time we think we have found the biggest or the oldest, space throws us a new curveball. If you want to see more of these cosmic mysteries explained, make sure to hit that subscribe button and join us for the next part of our journey. Because the more we understand the terrifying scale of the universe, the more precious our own little world becomes. Until next time, keep looking up.